Hello everyone, and welcome to Global Azure Bootcamp Virtual Edition. I'm hoping that everyone can hear me, and thank you for joining in, especially on my session. I'm humbled that so much of you are here, so let's not waste time and get straight to the point. So my name is Pieter van den Ede. I'm Chief Architect and co-founder of Azure Belgium. I'm also a Microsoft certified trainer. You can reach me at Twitter or via email. And let's talk a bit about Azure especially. Azure is a brand, an Azure brand actually. We are a company doing 100% Azure since 2011. We have 3 Azure MVPs. 2 of them are in Finland. One of them is in Belgium. We have 55 people working for us, and 52 of them are working purely on Azure, so are Azure experts. And we have an average of about 14 years of experience within the company as a whole. We have various gold Microsoft partnerships. I've talked about the MVPs. We have several Microsoft certified trainers. We do provide a lot of training. And at the bottom right, you can see that last year we were Partner of the Year finalist in the category for application innovation. We are very proud of that, and we hope to do at least are all about cognition, and cognition is everything related to senses. So things like hearing, understanding things, speaking, all of those things are related to cognition, and that's what Azure and Microsoft try to bring with you with Azure Cognitive Services. And as a developer, why should you care about artificial intelligence, and why should you care about machine learning? It's a very good question that I sometimes get as well, and this is the reason actually, because some of the problems that we are facing and companies are facing nowadays are very difficult to solve using traditional programming. So things like interpreting a picture, interpreting an object in a picture is very hard. Pictures or videos. There's recommendation engines in Azure Cognitive Services, which are not as easy to create when you have to do it yourself. Detecting failures in industrial processes, things like predictive maintenance is quite hard as well. There are obviously products on the market that do that for you, but they are quite costly. Azure Cognitive Services tries to bring a lot of that effort towards you already with a very low cost. And of course, there's a traditional example using artificial intelligence and machine learning, like self-driving cars and autonomous navigation of cars, and even motorcycles and bikes nowadays. So all these things are pretty hard to do on your own, and Azure Cognitive Services, or the set of services that Azure brings to you in Cognitive Services, tend to bring that to you and have that already provided by you within the cloud. Why would you use Microsoft Cognitive Services? As said, it's already there, so it's easy to use, and it's just a matter of calling the correct API. So everything which is available in Azure Cognitive Services is available through REST APIs, and it's very simple to call a REST API. It's very flexible because a REST API can be called from any device. Could be an Android or Apple phone, could be a Windows machine or Linux, or anything basically. There's also a lot of SDKs out there that Microsoft provided, SDKs for different programming languages. So it's very easy to use, very flexible. And I think the biggest advantage that Microsoft brings to the table with Cognitive Services is that they provide to you a set of services and we'll see what those services are quite quickly. They provide you with a set of services that are thoroughly tested. So it's not something that one person cooked up in their garage, trying to recognize some of the things. They are really thoroughly tested by the Microsoft research team, by the Bing research team, and they are using the Azure technology to provide you thoroughly tested and thoroughly functioning APIs, which you can lean on, basically. There's obviously a lot of documentation involving any Azure service, basically, a lot of sample code, and of course, there's always community support, things like Microsoft Forums or Stack Overflow, and GitHub is something you can always count on. So before we dive into Azure Cognitive Services, I think it's really important that we take a look at the machine learning process. So it's basically a 5-step process. The first step is all about data. So getting enough data and getting the correct data is always the first step, and is often the most difficult step. Getting the correct data, and nowadays it's all about gathering data and then storing it for future analysis. Getting the data is crucial. So this is the first step, getting the data. The second step is all about cleaning, preparing, and manipulating the data. What does that mean? It means that any data that is not correct, you should not be providing that to your machine learning algorithm or to your model to train on. And I can give a simple example on that. If you have an IoT sensor, for example, which measures temperature, there could be any glitch going on that, for example, instead of a temperature of 20 degrees Celsius, you get something like 2000. And it could be a glitch in the system, it could be a glitch in the network, could be anything, but that's not something you would want to give to your training model or to your machine learning model to be trained upon. Cleaning that data, making sure that the data you want to train your model on is there and is correct is very crucial to your model training and to your system as a whole. Fourth step is about testing that. Third step is about training the model. So this is all about using out-of-the-box functionality within Azure to be able to train your model on the data that you have prepared. So training your model, it basically means having some input variables and some expected output variables, and you would want to use real data for that, real input and real output. So at some point in your model will try to extract or try to predict what the output will be based on the input. Your data will actually, your model will be trained on your input data, and the fourth step is all about testing data. And typically, your test will use about 20 to 30% of your data set that you initially provided to train your model, to be able to test your model. So how well is my model doing in predicting what it should predict? So given that you have 2 input variables and 1 output variable, if my model has been trained, I would want to know, percentage-based, for example, how good is my model at predicting the output. So all of your input data gets divided in 2 parts. About 70 to 80% of that data goes towards training your model, and then 20 to 30% of your data, which your model has not seen yet, and that's an important fact, is used to test your model. So based on that test in step 4, you get your feedback on how well is my model doing, and depending on that, you might want to go to a 5th step, and that is all about improving your model. And this machine learning process is very important to know, because I will be showing that to you in the custom vision portal in a moment as well. So let's take a very high level look at Azure Cognitive Services, because there are a lot of services available there, and all of the services in Cognitive Services are categorized in a few categories. So there's decision, vision, language, speech, and web search, as you can see on the screen. So vision will be looking at that very shortly, but let's very quickly maybe take a look at the other ones, like decision. There's anomaly detector, content moderator, and personalizer. Anomaly detector will typically get input data and detect any anomalies coming from that. So the example that I gave you earlier on the temperature sensor, where all of a sudden it spikes from 20 Celsius degrees to 2000 and back. This is exactly what we would call an anomaly, if that's not something that is happening very often. So anomaly detector, for example, will do just that. Skipping to language, translator text is all about translation. So as you know, Bing Translate is a thing that exists. Google Translate is maybe for some of you better known. That's all provided as well. So you can provide your input text in a certain language. I think, if I remember correctly, there are 26 languages that have been provided at some point in Translator, Cognitive Services Translator. So you can translate from any language to any language, or at least the languages that are spoken the most. Bing Spell Check is a grammar and spelling checking service, and there is language understanding. It's called LUIS, Language Understanding Intelligence System. So LUIS is mainly used for the bot framework, for example, using chatbots in Azure. That's one of the underlying services which you can use to do neural language processing. So moving on to speech, obviously there's the typical interfaces like text-to-speech and speech-to-text. There's also speech transcription, and there's also the ability to use this in combination with the translation, so you can actually talk to your application which you've built. It processes the speech to text. It could translate it to another language, and then back again transform that text to speech. So that example is what Skype did a few years ago, to have semi-real-time translation. So you speak to your phone in English, it gets translated to French, for example. It speaks the French sentence to a person speaking only French. That one speaks back in French, and it translates to English. And obviously there's the last category, web search, which is everything related to Bing, the search engine. Things like searching for images, auto-suggest, new search, custom search, and so on and so on. But today we will focus on the one category that I haven't spoken about, and that is vision in particular. So let's talk a bit about the vision category in Azure Cognitive Services, and those are the main components that are available there. So first of all, there's computer vision, and that's quite a wide category, and a lot of REST services are available there. Things like color detection, so you give it an image, and typically in this category of vision, there's always pictures and videos involved. For example, it can detect the color scheme within the picture. What is the main color? What is the background color, and so on and so on. It could detect people as well in a picture. It could detect how old they most likely are. Are they looking happy? Are they looking sad? Things like that. A lot of services there, and I'll come back to that in a bit. Custom vision is something I'll go a little deeper today, so I'll skip that one for now. There's the Face API on the top right. The Face API will provide additional services, things like detecting how the eyes, where the eyes, eyebrows, mouth, nose, all of those things are located within a picture or a live stream. So that's very interesting if you would want to know where person is looking at, for example. There's form recognizer. I'll be talking about that one as well today. There's ink recognizer. Um, ink recognizer is typically something you see when using tablets or touchscreens. When working with a stylus pen, you are writing everything down in an application like Microsoft OneNote, for example. When you are actually going over the screen, you are creating a time series events with X and Y coordinates, and based on that information, it will actually try to convert your digital ink into text. So that's quite interesting. And last but not least is the video indexer, which you can compare a bit to your private YouTube. Things like giving it a video that you've downloaded or that you have created. It will extract which people are in the video, if they are happy, if they are sad, so sentiment analysis. It will analyze the text to determine what the topics are that have been talked about. It will try to determine the language of the text, and so on and so on. So today I will be mainly focused on custom vision and form recognizer. So let's get straight to the point. Obviously, I had a lot of fun doing these demos, and one of the things I found when researching this particular session is well, someone had this. This is quite the image that you are seeing on the screen is quite well known. It's a cross-reference based on X and Y axis of a rabbit and a duck. And someone, unfortunately it was not me, has come up with the idea and this is quite a well-known image as well, has come up with the idea to have an image like this, which is basically an optical illusion between a duck and a rabbit, and to provide that to a vision service. Now, in this particular case, it is Google Cloud Vision API. But you can tell if your machine learning model has been trained on these images, that even vision services, so things like Google Cloud Vision or custom vision, are actually also confused in the nature of the image. And as you can see, while it's rotating, it's sometimes determined as a duck in the blue color, and also sometimes as a rabbit. So even vision services are sometimes confused. So let's talk about custom vision a bit more in detail. So custom vision is a portal and a cognitive service that Microsoft provides within Azure, and it allows you to very easily train a model by just uploading within a portal some example images. So as you can see on the screen, the image that I've shown you here, and which is also available on the Microsoft website, is about a fridge which has cans of soda in there. So this is one example. I have another example lined up for you in a minute. So what you can do is you tag pictures. So what you take pictures, and in the picture you say it's either object A or object B, or you classify it as a dog or a cat or something similar. So training your model becomes very easy. So you provide the input images, you provide the information. So where can I find this soda can? How many are there? Things like that. So you can train a model very easily just using this custom vision portal, and it will allow you to provide a REST API as well, just by out of the box within the portal. So custom vision allows you to upload your own images, to label them, and to train a machine learning model already pre-trained by Microsoft to make it very easy for you, and to recognize objects or to classify images. So you can do it very fast, meaning only 50 images are needed to be able to build a prototype. And you can also keep improving your model by providing it with more data, and increasing the number of iterations. Once you are satisfied with your model, you can publish it as a REST API. So these are the steps. Upload your images, you can tag them, you train the model. This, of course, will require some compute power, and then evaluate your model. Is it doing well enough? And if it's not doing well enough, you go to the famous step 5 in the machine learning process. You improve your model by adding more data or by fixing your tags, for example. Time for a bit of a demo. And as you can see, and already saw in the beginning of in the first slide as well, I've used playing cards for this demo. So the setup of this demo in particular is that I have a Power App installed on my cell phone. My cell phone is connected with my computer, so you should be able to see what is on my cell phone on the screen. I will be able to take a picture in this Power App. The first step is that the picture will be uploaded to Azure Blob Storage. It will be uploaded to a blob container, and when I click a second button called Predict, from Power Apps, I will call a Power Automate flow, which is a Microsoft flow. Microsoft flow will contact or connect to the custom vision prediction REST API that I published earlier. And the response that I'm getting from that service, I will put that towards an Azure function. And this Azure function will try to determine what is the most relevant card that has been recognized and show that to you within the Power App. So let's see. Let's take a look first in the Custom Vision portal. So if you go to customvision.ai, you can find a lot of documentation there. So what I've done is I created a new project in the Custom Vision portal. Excuse me. And I've taken a lot of pictures of playing cards. So I have a playing card deck, and I took a lot of pictures, as you can see. I even have some late at night, in the morning, to have a different lighting. That's also very important, that you have a lot of variety in your pictures. So you could have dark ones, you could have lighter ones, cards that are rotated. You would want to teach your machine learning model all kinds of variations so that it is able to recognize a card in pretty much any situation. So as said before, you need at least 15 to 50 pictures per object. And what I've done is I created a lot of tags right in here, and each tag is one card. So as you can see here, for example, I have about 69 pictures of aces involved. I'm not sure why it's not showing it. Yeah, there it is. So I have a lot of pictures taken, and I use that to train a model. So within the Custom Vision portal, on the green button, you can click it and you can provide a quick training. And the quick training is pretty easy. It's about 5 to 10 minutes worth of compute time, and it will quickly show you a bit of results that you are expecting. This is the kind of training that you would want to do when first starting out with your model. If you have some pictures, it would pretty much tell you very fast after uploading the first few batches of pictures and tagging them. It will tell you very fast if the model is working or not. Does it need more data or not? So this is the quick training. The advanced training will require some more compute time, and obviously Azure is a cloud platform, so compute time will cost a little bit of money, and you can go from 1 hour to 24 hours training budget to let it learn your data, your model, and to learn what the images are representing. So once you have trained your model, and you can see that I'm currently at iteration 8. So this is all about improving your model. I first started out with iteration 1 and then quickly moved on to improve my model more and more. This is iteration 8, and you can see that my precision is quite high. It still is machine learning, and it still is artificial intelligence, which means it will not be perfect. Although it is able to recognize cards very nicely, sometimes I do get the strange result. So this is all about adding more and more pictures, so getting more data and improving your model. Once your model is satisfactory, you can, let's click on iteration 6, which has not been published yet. You can publish right here on this button. You can publish your training model, and it will provide to you, or it will give you some keys and an URL. I will not click the button because otherwise you would see my authorization key, but it does give you the capability of predicting or sending your image towards the REST API, where your training model that you have trained within the portal is in the backend, and it provides you very easily a REST API that you can call from any device. So I think that's about it. Yeah, the other one is for later. So what I've done in Azure, and I have my first resource group is on the left side. I have a storage account here to store some of my pictures results. I have an app service plan. I have an application insights for functions. I have, of course, a cognitive services service, and I do have an app service which hosts the Azure function I talked about earlier. So maybe it's a good idea to start a demo. And for this, I am connecting my phone to my computer, and I will. There you go. There you have it. So let's first set up the camera. There we go. So as you can see, this is a live demo. What I did, I took a normal set of playing cards, and it's just a regular set of playing cards. And what I did is as you could see, I took a lot of pictures, but I did not, because there are a lot of cards within the playing deck. I do have to confess that I did not teach all of those cards to the machine learning model. So what I'm going to do is just shuffle the deck a bit. There we have it. I'm just going to take a random card, and I'm going to put this here, just out of the way. I'll stop the camera. I'll start Power Apps. And what I'll do, as you can see here, there's two buttons on the screen. One of them is upload, one of them is predict. So upload will, let me just start the app again. So the camera should work. There we go. So what I'll do is I'll just take a picture by clicking the upload button. So this will take the picture and upload it to the storage account. And once this has been done, I will click the predict button. So hopefully then the backend, which is a Microsoft Flow, will kick off, call the computer vision API, call my Azure function, and get me the picture, which is predefined here, the tag and the probability score for that picture. So let's first click the upload button. Let me try that again. Yeah. So now, as you can see, it's uploading to Azure Storage. You can see that at the top where it's working. So now it has uploaded to Azure Storage, and now I am clicking the predict button. It will now call the custom vision API, call my Azure function, and my Azure function gives me back the tag of the card, which has been recognized. And as you can see, that's the correct one with a probability score of 80.6%. So this is quite high. I can do that for other cards as well. So let's take another card. So you see I'm not playing you. Let's click the upload button again. Uploading to Azure Storage. Should have been done. Let's predict that. Now it's calling custom vision API, and there we have it, the king of spades, which is the correct one with an 87% probability. So this is nice. Let's take a look a little bit more in detail on how it works. So here I have the Power Apps portal. If you haven't heard about Power Apps yet, it's a low-code platform, as you may call it, which very easily, with a minimal set of code, allows you to create wonderful apps. I'm not saying my app is wonderful, but it does do the trick. I could do some UI tweaks, of course. This is my application that you've just seen. And here, when I click the upload button, you see what code. It's just 2 lines of code that is behind that. So I have my camera control here, which is called camera 1. Once I click the upload button, it will take the stream, or basically the picture, and save it to the variable called picture to predict. And then I'll just create a file on Azure Blob Storage in the cards upload container. The file itself will be called predictme.png, and the content of the file is the variable that I just taken from the camera1.stream. So it will upload that towards Azure Storage Explorer, and from there, the response I'm getting back from there, I'm putting that into this particular variable. Once I click the predict button, I have here Microsoft Flow, which I run, and then the contents or the response that I'm getting back from that flow, and that's something we'll take a look at in a moment. I'm putting that into var single card result variable. So the var single card result is actually just an object which contains a few details. It contains a tag. The tag is the tag that I'm getting back from Custom Vision, and as you can see in the Custom Vision portal, when I go back to the images, okay, it should give me something like clubs of ace. So this is a tag. Here we get the probability score. There's that one. And then for the image, I'm linking towards a specific Azure Storage container where I pre-uploaded pictures of cards already, which you can find on the internet. So I can show you the exact card on the screen. So how does my Microsoft Flow look like? It has a Power Apps trigger. So the Power Apps trigger is no code because it's just called from the Power App itself. I will call the URL, so the image that has been uploaded to my storage account. I'm calling that from. I'm providing that to the custom vision API for a certain project ID. The response I'm getting back from that, I'm providing it towards an Azure function. The response I'm getting from my Azure function, which basically contains a tag, a probability, and a value. I'm parsing that as JSON, and I'm responding back to the Power App just by providing tag, probability, and value. So as you can see, it's very low code, very easy to create. The only thing that I haven't shown you yet is this one. And let's zoom in a bit. There we have it. Here I have my function, which is taking in the input that it's getting is actually the one that it's getting back from the custom vision service. I'm deserializing this into an object. I won't bore you with the details of how the class looks like, but what I'm doing is I'm trying to get the highest scoring prediction. So I'm checking, I'm ordering rather by probability descending. So I'm taking the highest probability for a card that is there, and I'm taking the first result. So from that highest scoring prediction, I'm getting the tag name, the probability, and I'm also doing some stuff to get the card value, which I'll show you in a minute. So that's pretty much it. That concludes my simple demo for recognizing one card, but it would be a bit boring to just stop there. So what I decided, or what I did, I created a second Power App. So first, let's close the other one. And the second one can actually take multiple cards. So I can start out with just the King of Spades. So this app just has, again, the upload and the predict button. Upload will upload to a storage account, and predict will show you one or multiple cards with their blackjack value. So let's take a picture first by clicking the upload button. Voila, now it's been uploaded to Azure Storage. And now I'm clicking the predict button. It will call a different flow. And currently it does recognize the one card with a value of 10. So for people who are aware how blackjack works, every card has a value. For example, the king has a value of 10, and an ace can have a value of 1 or 10, for example. So let's maybe add a different king to the table. Let's retake the picture, upload it to Azure Storage, and let's try to predict it again and see if it recognized both cards. Let's click the predict button. There we go. We have two cards with a value of 20, and let's add another ace to it. Clicking the upload button again. Uploading to storage. Clicking the predict button. There we go. We now have blackjack value of 21. And if we do get burned, there's always a reset. So that's how it works. So that concludes this particular demo. let's get back to the presentation. So this was the demo, Power App, taking a picture, uploading it to storage, predicting it via calling a Microsoft Flow, calling custom vision, and getting back the response from the custom vision REST API that we published earlier, getting that response towards my Azure function, processing it, and getting back the results in my Power App. Very easy. The second service I want to talk to you about, and I still have about 15 minutes left, I think, is Form Recognizer. And why I wanted to talk about Form Recognizer is that I haven't seen a lot of demos involving Form Recognizer yet. And I think it's something, it's a service within Azure Cognitive Services that is not very well known, but I think it can provide a huge benefit for people and for companies everywhere, actually. So what is Form Recognizer? Form Recognizer is, again, as usual within Cognitive Services, it is a REST API or a set of REST APIs. You can send it and you can train it to learn to extract text and structure from documents. So things like PDFs, pictures of an image, for example, you upload that towards Azure, or you upload that towards the REST API. You can get back information from there. And what's really interesting here with Form Recognizer is that, similar as to with the custom vision portal, you can have a REST API where you can teach that a picture of a certain receipt, for example, and the receipt that you see on screen is the one that is shown within the Azure Cognitive Services documentation. You can learn it to recognize the certain layout of a receipt which you get in a shop, for example. You can have it train on certain forms that people tend to fill in, and so on. So it's a bit hard to grasp if you haven't seen it yet. So maybe I'll just show you the demo instead. So what I've done, first of all, is I went to the Cognitive Services documentation for Form Recognizer, and what I did is I've installed I installed a Docker image, and the Docker image is from Microsoft, and it's a Form Recognizer image. So it's a sample labeling tool which allows you to train a model within the cloud. So what I did is I've installed Docker, I've pulled in the sample tool for the sample image for the labeling tool from Microsoft, and I've just run it using this service. This is perfectly something you can do as well. So let's take a look. So I've pulled the image, and now I'm just running it. And by running it into a Docker container on my local machine, I now have here on my local host 3000 port. I have here, or you can open an existing project. And what I've prepared is then to have a parking receipt. Let's see. Doesn't seem to be responding a lot. There we have it. Yeah. I think the container was not spinning up correctly. Let's try it again. Okay, there it is, I think. Great. So I'll give it a bit of time, but in the meantime, I'll explain you some of the stuff I did. Both me and my colleague at Azure Belgium, we both had a lot of parking receipts in the beginning, before we actually had a private spot in the parking. So what we did is we've taken all of our receipts and we've taken pictures of them. And this tool, and I'll go a little bit into detail, this tool allows us to, it does OCR on the picture of the receipt, and this tool allows you to actually select the text which is detected and attach a tag to it. So for example, you have the tag parking, which is the name of the parking, and it can, this has been determined as Q Park Zuiderpoort Gent, which is the location of our company. You can provide a VAT number, you can provide a start and end date, and I think for most of us, especially in receipt and expenses, for receipts and expenses, there's a total amount, which is also very important. So what I've done is I did this for about 5 receipts, and you can see them here at the left side. And what I've done is I've trained the model here, and it just took me about half an hour, I think. I trained the model, and from there I'm now able to do a prediction as well, just as I could do for the custom vision portal. Now I can do that for form recognizer as well. So what I can do is I go to the predict stage of the tool, I browse for a local file, and I can just select this one. And you can see the images that I've trained it with were all vertically aligned. This one is actually horizontally aligned, and it does have a crease into it. So let's run the prediction here by clicking the button, and let's see what this gives us. Extract the information from there. So as you can see, even though the alignment is completely different than the ones it has been trained on, it does recommend and so on, and we do have a total amount of 10.5 euros. So all of this is quite easily interpreted, and what you get from the API is actually just a bunch of JSON. So let's try to open it up in Visual Studio Code. Let's save it as a JSON file. So we are able to format it correctly. There we have it. So let's zoom in a bit on that. What you're having is a text Q Park Zuiderpoort, which is the name of the parking. There's a lot going on here, but basically all of the tags that you have provided, it will try to analyze them. It will try to parse them, and it will give that to you in a JSON format. This could be very handy if you have receipts from a lot of employees within your company that have been bringing in receipts, and people need to analyze them manually and write them in. So this could all be automated by just using, let's say, 5 to 10 examples. So this is quite interesting to see. So let's get back to the slides maybe. One thing I'd like to mention as well is that something exists that are cognitive containers. So cognitive containers, what are those? And I think for some people it might be interesting still to see if there's what are containers. So I'm not going to, because I'm probably going over time already, I'm not going to go too much into details, but there is a specific difference between virtual machines and containers. So before we talk about cognitive containers, let's very briefly talk about what is the difference between virtual machines and containers. So I found this nice graphic here, which shows you that pretty much within virtual machines, you do have to take care of the operating system. Operating systems are typically very slow. If you boot up your machine, it does go quite quickly. Booting up a server machine can take a bit longer, but an operating system, you'll still need to manage that, and of course it takes quite some time. With containers, it works differently. So you can focus mainly on the application itself. It spins up a lot faster, and it's just easier to manage as well. So the difference, VMs quite heavyweight. The performance is limited because of the overhead of the operating system. If you have to run 5 or 6 operating systems on your machine, on your physical machine, all of them will have overhead, while as containers, they are quite lightweight, and all containers share the same operating system, so it goes a lot faster. Therefore, the startup time is quite fast as well. It requires a lot less memory because you don't need to load all of these services and application in the background, which are key to the operating system, and it runs less isolated than a VM, but that's not really important right here in this context. So cognitive containers are actually containers that are not running in the cloud, but you can actually install them on your cell phone even, or you can install them on your Raspberry Pi in the edge or anywhere basically. And what does that allow you, and why is it so interesting, is that if you have a lot of data going back and forward, for example, the demo I just gave you with the playing cards is just an example. You have an image or a video that is constantly sent back and forth over the internet. That's not something you would want because it takes a lot of data and it requires a lot of bandwidth and a very strong internet connection. If you can bring out that model and put it on premises or somewhere where it's very near to the application or system where you actually need it, you don't have to spend a lot of time uploading or downloading that data. So your data is not sent over the internet, which means less traffic, and of course, privacy-wise, it's a huge difference if you can keep your data within your virtual network or on premises, for example. You have full control over the model updates if you use cognitive services. It's portable, of course. You can run the same container in Azure on premises or on the edge. And due to the fact that you don't have to upload it constantly towards the internet, it gives you lower latency and higher throughput because it runs physically closer to your application. You could say running the cognitive container will be more interesting because I will not have to pay for it. Think again, because you still need an internet connection towards Azure, because the billing information, so for each image or video that is sent to your container, you will get billed by Microsoft. And you could play smart by killing the connection between your container and the internet, but in about 15 minutes of time, your container will stop working. Actually, it will not be able to do anything anymore unless you open the connection up again. So what of the cognitive services are available? Anomaly detector, computer vision, the face API, form recognizer, as I've just shown you. Lewis, language understanding, is available as well, just like the speech service and text analytics. There's probably more to come, and Microsoft is still working on them. I'm sure that at some point this list will be extended. All right, so before I close off, because it's almost time, I do have some more resources. I've talked to you about all of the services that are available in the computer vision and computer vision category. At this particular address, I've compiled a set of requests in a Postman collection, so you can get that. You can download that from GitHub and play along with it. It does show you the versatility of what is available there. There's also Microsoft Learn, where you can get knowledgeable about a lot of things like this Cognitive Vision Services course or learning path, where they teach you about computer vision and custom vision in particular. There's also language services, so anything related to the language category. Anything related to speech is found here. There's also a new addition to, well, it's not quite as new, but there's a new addition to Cognitive. Azure Search has been renamed a while back to Azure Cognitive Search, but I decided not to include it within this presentation. And I think maybe the most important one, or if you're looking for real in-depth details to learn about Azure Cognitive Services, you can go here. It will redirect you to a Microsoft page where you just leave your email address and you are able to download a free book from Pack Publishing. And it's really quite good. It's 300 pages plus, and it's completely free. So that's very, very interesting. This presentation material in itself can be found at this address, together with the source code of the Azure functions that I showed you a bit about as well. So with that, I conclude my session. I've been talking for an hour or so. If there are any more questions, please feel free to put them into the chat. I'll be happy, if you leave a comment or a chat, I'll be happy to get back to you later as well. This recording will stay available online on YouTube. So I hope you got everything you wanted out of this, and I hope to see you again at some point. Thank you for your time. Thank you for your attention. I hope you enjoy Global Azure Virtual as much as I do. So have a great day. Goodbye.